We are starting with 5.3, and again, we're gonna like jump back and forth a little bit because this book does things in slightly different order than usual. Okay, so we're gonna talk about rules for integration. Remember how when we started talking about derivatives, first it was the definition of the derivative, so it was limit as h approaches 0, f of x plus h minus f of x, right? And then we learned the rules for derivatives, right? So like the power rule, bring down the power, and so on. So same thing here. First we started talking about integrals by finding areas. Now we're going to talk about some rules for integration. Okay, so the first rule is the order of integration. All right, so take a look here. This is how we're usually used to seeing an integral. It's the integral here on the right-hand side, a to b f of x dx, right? But take a look at what's happened here. Here, it's the integral of b to a. So instead of going from a to b, now we're going from b to a. I should say, before I even start here, we're looking for when, you know, a and b and c are in this order, right? A is less than b, less than c. So when you have the integral from b to a, so starting at a higher point and going to the left, that is the negative of the integral from a to b. So for example, if I wanted to look at, you know, the integral from 5 to 3 of f of x dx, we're going in the wrong order, right? Like in the wrong direction. That's the negative of that same integral, but from 3 to 5. So you can find the integral from 3 to 5 and just put a negative in front. Okay, take a look here. Here I'm looking for the integral from a to a. What was integral conceptually? It's area, right? So if I wanted to find the area of something from a to a, how much area is there? 0. So the integral from a to a is 0. Constant multiple. If you have a constant times f of x and you're multiplying and you're looking for the integral, okay, you can take the constant out. So for example, if an integral is the area of a rectangle, okay, so I have my rectangle. If I wanted to find the area of 5 times the rectangle, I could just find the area of the one rectangle and multiply it by 5, right? So we can take the k out. Here, if I have the integral from a to b of f of x plus g of x, I can split it up. So if I have, you know, one area plus another area, I can do them separately. So for example, you know, if I have, let's say, the integral from 0 to 3 of, I don't know, the square root of 4 minus x squared plus x cubed dx, okay? I can split this up and I can first find the integral from 0 to 3 of the square root plus separately from 0 to 3 of x cubed dx.
But does not make it, couldn't that be harder though? Could you just do that all as one function though?
Yeah. Like it can be split up, yeah, or it doesn't, right? Yeah. So it's, yeah.
Why is it just a square root?
Because I got lazy.
It was just the format.
Yeah, it was just the format of the one before, yeah. Okay, so now take a look at this one. Here I have the integral from a to b of f of x dx. And then I have the integral from b to c of f of x dx. It's the same function. First I'm finding the area from a to b, then b to c. Well, that's just like saying it's the total area from a to c, right? So that's the total area from a to c. Okay? Okay, so take a look at what we're given here. For some function, we are given that the integral, or area, from -1 to 1 is 5. from 1 to 4 is negative 2. And then from negative 1 of some other function, h of x is 7. We're going to use that to figure this stuff out. Okay? I love these. These are like little puzzles. So, look at this one. This is asking me, part A, is asking me for the integral from 4 to 1. So that's just the negative. This is the negative of the integral from 1 to 4 of f of x dx. So that's just positive 2. Okay? All right, so here I have negative 1 to 4, right? Okay, what I'm given is negative 1 to 1 and then 1 to 4. So this is negative 1 to 1 f of x dx plus 1 to 4 f of x dx, right? It's the two little parts combined. So that's 5 minus 2, 3. Yep. Okay, here. Here I have negative 1 to 1 f of x plus h of x. So this is like negative 1 to 1 f of x dx plus the integral negative 1 to 1 h of x dx. So the integral from negative 1 to 1 is 5 plus 7, 12. Okay, here, from 0 to 1, f of x dx.
Would you use additivity? It seems like it's impossible at first glance.
So what do I have? I have from negative 1 to 1 f of x dx. But how much is the area just from 0 to 1? Do I know what f of x is? I have no, well, how do you know? Because maybe it steeps up and then comes down. There is no way to tell. So there is not enough information.
But like, let's say you were given from negative 1 to 0, then you could do it, right? If you had negative 1 to 0,
No.
you could say, yeah, because you could say negative 1 to 0 plus 0 to 1 equals negative 1 to 1, which is 5, right? Yeah, you'd have to know like one other piece.
Oh, if in addition to this,
It
I
gave you
was given,
negative
yes,
1 to
yes,
0.
yes. I thought instead of this, if I was given. Oh, yeah, yeah.
Okay, cool.
Yeah. So from negative 2 to 2 of h of x dx, I have negative 1 to 1.
So we don't know.
Now I'm being asked for negative 2 to 2. I have no idea how that function behaves. Like, I don't know if it's symmetric or on 0. So I have no idea. So it's not enough information.
Is that what you read on like a test, or it wouldn't be on a test? It's like
Something
sometimes
this
you-
simple won't be on a test. No, yeah. I mean, it might be on my test, but it won't be on the AP test. Not enough info is good enough. So here, okay, so the way you can rewrite this is, you have the area, you have 3 times the area from negative 1 to 1 of f of x dx minus the area from negative 1 to 1 of h of x dx. So this is 3 times 5 minus 7, which is 8. Okay. One very, very important thing is this. Once we come into this stuff, right? Once we start using integrals, please recognize that this symbol can never exist alone. Because what is this symbol? The symbol is just a sum, right? It can never exist alone. This symbol can only exist with a dx attached to it. Okay? So you can never write integral blah blah f of x, never. these two have to appear together, and they have to go away together, and they have to disappear together. Okay? It's like if you were writing, instead of writing times for multiplication, like instead of writing that, if you only wrote like half of it, right? Like that's, you know what I mean? So leaving out the dx is like leaving out half of the times for the, you know what I mean, for that operator. It doesn't work like that. Okay. So now I'm going to teach you some of the rules for finding integrals of functions. This is from section 6.2. So yes, this is where we're going back and forth a little bit. Okay. All right. We're going to talk about what it is to find an indefinite integral. Okay, so we know how to take a derivative of a function. Okay. Now, if you take a derivative of a function, and then if you go back to the original function, you've done the opposite of taking a derivative, right? We call that the antiderivative. The family of all antiderivatives of a function is denoted by integral f of x dx. So now we have two parallel definitions of the integral symbol. One is the area, okay, under the curve. The other one is the antiderivative of a function, the antiderivative. So if f is a function such that f prime is little f, okay? So little f is f prime. Then the integral of f of x dx is capital F of x plus c, where c is an arbitrary constant. All right? So let's talk about some things here.
So what it's saying is,
Hang on, I'll tell you what it's saying. Okay, so what we have here is the derivative of some function, right? That's f prime, the derivative. That is f of x. So one is a derivative and one is an antiderivative. Basically, what you're saying is, if little f of x is the original function, okay? Then, okay, so here's what it's saying. The derivative of the antiderivative is the original function.
I'm just confused with that antiderivative.
I'll tell you. So look, suppose f of x is x squared. Okay? That's my original function. Let's take a derivative of this. What do you get? 2x. This is telling you that if you take an integral of the derivative, the integral of the derivative dx, the integral is the antiderivative. So if this is the derivative, if we wanted to undo the derivative, what do we get back? X squared. Though instead of saying the words, let's undo the derivative, why don't I say integral 2x dx? This is telling me undo the derivative that got you 2x. And you get, I'm going to tell you, and you get x squared, okay, plus c. Okay? Why plus c? I'll tell you why plus c. Because imagine if I had a function Okay, so presumably now, what we've done is found something so that when I take a derivative, I get 2x, right? When I take a derivative of this, I get 2x. Okay, so if I have x squared and I take a derivative, what do I get? 2x. What if now I have g is x squared plus 3? What's g prime? 2x.
But you lose the plus.
What if I have h of x equals x squared minus 7? H prime is 2x.
So we don't know.
So when I took the antiderivative, I found all of the functions so that when you take a derivative, you get 2x. Okay? That's what a derivative does. This is why up here, there was a word which we glossed over and you didn't even know what it was. It's the family of all antiderivatives, the family. So you find all of the functions. Okay? All right. We're going to go plus c gives you, so basically it could be x squared plus any constant. And instead of saying plus any constant, I say plus c. Okay, now, let's talk about some properties of indefinite integrals. Okay, there's another word that I glossed over and now I'm going to go back in that first sentence is loaded with like important words. The next word was here, the antiderivatives is the indefinite integral. Indefinite integral means no limits of integration. So there is no, a to b. It's just integral. Okay.
You never have like infinity.
No. I mean, you do, but in BC.
Oh, you just don't put bounds
That's
on
the
it?
same thing.
Mm. So
So if you didn't
you
put
just put bounds
bounds
on it.
on
Let's go.
in your calculator, would it do it
Um,
for the indefinite or
no.
it's too complicated?
Yeah, it won't.
Sorry.
The CIS will. Okay, so this one we already know. So this is from 6.2. The first one, k times f of x, is the same as k times the integral. The k comes out. We already did that one. This one we just went over as well. If you have the integral of f of x plus g of x, you can split it up. So it's the integral of f of x plus the integral of g of x. So it's the same thing as we had up here, but now, like in the beginning, we had limits a to b. Now I don't have limits a to b. All right? Okay, now let's talk about the power formulas. If you have an integral of u to the n, okay, the antiderivative is u to the n plus 1 over n plus 1. So basically what you do is you add 1 to the exponent and you divide by the new exponent. But then you have plus c. This c is called the constant of integration. It has its own name. And it's always plus c. Don't go doing plus k, n, l, whatever, okay? It's plus c. It's plus c. Okay? So there is one rule. So for example, going back to that problem before, I kind of gave you the shortcut version. If I have integral 2x dx, the 2 stays because it's just a constant. And then I have x. The original exponent was a 1. Now it becomes 2. And I divide the whole thing by the new exponent plus c. That's how I got x squared plus c. Okay?
Wow. just you wouldn't square the 2.
No. It's only the
Non-constant.
non-constant. Okay, so think about this for a minute. Let's think about this for a minute. If f is x cubed and I wanted f prime, what did I do? I brought the 3 down, and then what did I do to the exponent? Subtracted 1. Now, because I'm taking the antiderivative, I have to add 1 to the exponent, right? So this gives me 3x squared. Now, how do I go back? How would I go back? I have to undo what I did, right? I have to undo what I did. So I subtracted an exponent. Now I have to add it back. So plus 1, 3. And then I have to divide by that in order to get x cubed back.
So you divide by.
Yes, it's the antiderivative. That's what we're doing. Yeah.
So you divide. So if it's you go back. So in the 3x squared problem, the cube problem. The derivative I understand is 3x squared, and then you take that same exponent that you already squaring it to the derivative, and then add 1 for both the numerator and the denominator.
No. Let's do a couple of examples and you'll see. All right? You add to the exponent and divide by the new exponent. Okay, so here's the next rule. U to the negative 1. How do we write u to the negative 1? It's 1 over u du, and the integral is ln of u plus c. So the integral of 1 over u is ln of u. So here's a question for you. Look just at the last part of this. ln of u. Hey, what's the derivative of ln? What's the derivative of 1 over u? So the integral of 1 over u is ln of u.
Why is it an absolute value instead of like?
Because why is it not an absolute value? Because you can never take the ln of a negative number, because that means raising something to an exponent and making it negative. That's impossible. Okay, so next one, trig functions. Okay, so listen up. Look here for a minute. What's the derivative of sine x? Derivative of sine x is cosine x. So the derivative of cosine, the integral of cosine is sine. Okay? Now, the derivative of cosine is, okay, Eli, hang on. The derivative of cosine is negative sine, right? So there is a change of symbols. So the integral of sine is negative cosine. It's switched from the derivatives. Be careful. Same thing here. The derivative of tangent is secant squared. So the integral of secant squared is tangent. All right, we're going backwards. Let's do secant. The derivative of secant was secant tangent. So now in the integral, I need secant tangent to give me an antiderivative of secant, right? And then, we have opposite signs over there. So the integral of cosecant squared is negative cotangent, cosecant cotangent, negative cosecant, and so on. All of these have plus c. Okay, what's the derivative of e to the x? E to the x. So the integral of e to the x is e to the x plus c. The most common place where students lose points in these problems is they forget the plus c. And I am making you a promise. You will lose points every single time. There is no grace period. Okay? Okay.
Yes.
Oh, you need to memorize. You need to memorize every single one of these. I mean, you need to memorize.
I know you want us like learn it and actually know it.
Well, we know it now.
Well, I know you.
We learned.
No, memorize it.
It's already right.
You already know the, one way, so you do the other way. Okay, so find each indefinite integral. Whenever you hear the words indefinite integral, you have to add the plus c. Indefinite integral, you have to add the plus c. So, this one, let me do a couple and then I'll start taking questions. This is a basic power function. So what you have to do is you take x, you add 1 to the exponent, it becomes 3. And now you divide by the new exponent plus c. Now, mentally, check. The derivative of this is 3x squared over 3, which is x squared. The derivative of c, that's a constant, is 0. So the derivative of all this is the original x squared. We are finding the integral, aka antiderivative. All right? So here, the derivative, the integral of 2 cosine x, the 2 is just a constant, it's a 2. The derivative of, now I have to switch my frame of thought. Integral of cosine is sine x plus c. Hey, is it negative? Is it positive? I don't know. Let's go backwards. What's the derivative of sine? Positive cosine, so we're good. Okay? The derivative of cosine is negative sine, but the derivative of sine is cosine. It's the opposite.
It's derivative of cosine of sine.
The derivative of cosine is negative sine.
Oh, it's okay. That makes yeah.
Okay. Integral of e to the x plus c.
Oh, like that meme?
That was the derivative. This is the integral.
Oh.
But there are countless means on the plus c. Like, oh, it's yeah, it's all. That's a.
I found the Instagram. I showed it to you.
So this one here, we have something minus something plus. So just like when we were finding derivatives, we did each term on its own. Here too, we're just going to do each term on its own. So the first term, it's going to be 2x, add 1 to the exponent, divide by the new, minus 3x, add 1 to the exponent, divide by the new, plus 8x squared, divide by the new, plus 4. Okay, this is really 4x to the 0, right? Because x to the 0 is 1. So now I add 1 to the exponent, it becomes x to the 1 divided by 1 plus c.
Oh, see, I was thinking just do 4 powers. Yeah, that's what I was.
No, yeah, you add the x. Because now, right, so what's the derivative of 4x? 4. Okay? So another way of saying this is, when you're finding integrals, find the function so that when you take a derivative, you get 4. Okay? And then the plus c. So we just put 1 plus c at the end. And then, of course, we have to simplify this. So this is x to the 4 over 2 minus x cubed plus 4x squared plus 4x plus c.
Have we talked about multiplying one from like?
We will.
Oh, well, we haven't.
No,
yet.
that's a whole other situation. Okay. Here, 3e to the x is just 3e to the x plus 2x to the 5 over 5 plus c. This is so much cool. This is so much fun. It's so cool. Okay, this one, I have 6x minus root x, right? Root x is still x to the 1/2. Nothing has changed, just like, last month. So this integral now is going to be 6x squared over 2 minus x to the power of half plus 1, 3 over 2, over the new exponent, 3 over 2. And this is the, like, I'll do this 1 or 2 more times, and then we're just going to take the reciprocal every single time, right? We're just going to get better at that. So this is going to be 3x squared minus 2 over 3, x to the 3 over 2, plus c. I should have had a plus c up there too. Okay? This is like, you know, when we learn limits, you know, I take points off for not putting the limits for every step. It's the same thing, except this is a little bit more because this is not just notation now. It's literally the wrong answer, right? Because the derivative of this is not just one thing. It's all, let's plus every single constant that you can think of. Okay, here, same deal. This is going to be x to the minus 1 over minus 1 plus c. So something divided by negative 1 is just negative. And x to the minus 1 is 1 over x plus c.
I thought from ln.
Nope. The integral of 1 over x is ln. This is the integral of x to the negative 2. The integral of x to the negative 1 was ln.
Why is it only x to the negative 1?
It's such a long answer. It's like half an hour of explanation. Yeah.
Don't worry, you got time.
I don't want to. I take it back. I don't
It's I dare not. It's yeah. Okay.
I'll miss my next class.
So this one we're gonna take the integral of negative sign. The integral of sign is negative cosine, and if it's the negative of that, then it's just positive cosine plus c. Okay. Yeah.
Is that why when it's talking about using the power function, it has a stipulation that it can't be x can't be or the n can't
It has to be greater than 1. Yeah.
That's that whole
Mhm.
other okay.
Yeah, because when n is equal to 1, then it's ln. Okay, so cosine of x plus c. But it's funny because nobody ever asks me why the derivative of ln is 1 over x. But every time when I teach the derivative, the integral of 1 over x, everybody says, why is it ln? Right? But when we learned if y equals ln of x, y prime is 1 over x, we kind of actually did you know what, I take that back. I did go over y.
It was like the shape.
It was
graph,
the,
right?
yes and no. I went over like algebraically why. But basically, it's a cool little thing, but it takes too long. Anyways, let's move on. This one, e to the x plus x to the power of negative 2/3 plus 1 is 1 over 3. Divided by 1 over 3 plus c. So this is e to the x plus 3x to the 1 over 3 plus c.
It's so easy to get one.
Yeah. Okay. Here again, we're going to write this as x to the 1/2. So the the integral will be 4 x to the 1 plus a half, so 3 over 2, over 3 over 2, plus c. So this is now the reciprocal, so 8 over 3, x to the 3 over 2, plus c. Okay? So now, if we go back here, I think you'll have a better appreciation of what this sentence was talking about. Because this is important for when we do like the next section. So if capital F is a function, right, such that the derivative is little f, okay? The derivative of this is little f. So now, when I integrate little f, I get capital F. Because the derivative of capital F was little f. Okay? That's where this comes from. But plus c. Okay? So, let's talk about that plus c for a minute. All right. So we said, all right, if f of x is equal to x squared, right? F prime of x is equal to 2x. Yes? What does that mean? What's f prime anyway? It's the slope of this, right? It's the slope. So the slope of this changes in a specific way, correct? Yes? So now, suppose I gave you the integral of 2x dx. What would you say that is? So now you have to find, if this is the slope, now you have to find a function for which this is the slope. So you integrate this and you get x squared, right? Or 2x squared over 2, which is x squared. I'm leaving out the c for a minute. So basically, you found this parabola. So you found a function, the derivative of which is this. But look at this one. What's this? This is x squared plus 1. Does this not have the same slope as this? It does. Look at this one. You know, like x squared minus 2. Does this not have the same slope as that? It does, right? So when you put the plus c, you are finding every single parabola with slope 2x, because that's what your task was. Okay? Yeah.